of planets become problematic because they might very well be black dwarfs, brown dwarfs, sorry. But are you including in this the 3 that are published as a companion article to yours in this issue of Science?
Excellent question. The question was about a different discovery. It's parallel and complementary to the one we're talking about here. First, I'll just summarize it briefly, then I'll address your question. It's a star called HR8799, and it's also a direct imaging discovery where 3 planets were found, and orbital motion of all 3 planets were seen around the star. And these planets are also quite far from their star, about 24, 40, and 60 times the Earth-Sun distance. This one I'm not including in the possibly unacceptable claims. This is also a legitimate discovery, but I want to add a couple of comments to that. What's so amazing about it is that we've never ever seen one star with 3 stars orbiting it sequentially. All the times we see multiple stars, 2 would be orbiting each other, and then those 2 pairs would be orbiting each other, etc. So that alone is remarkable. The question about mass and what exactly is the mass of these triple planets is uncertain for the reasons I described, that you measure brightness and not a mass. But what's so interesting and why it's complementary to this discovery is I think that both discoveries are going to force us to re-question what is a planet. If you see 3 things orbiting a star that are close to what we want to call planetary mass, most people, I would say that also everybody will agree those are planets as well, despite what their mass is. So I think it's going to force us to relook, how are we defining mass? We've heard so much in the press about Pluto, and everybody wants Pluto to become a planet again. Many, many scientists do, much of the public, especially little children. And we actually have the same problem, but we're just not as catchy. We don't know the upper mass end. We're struggling a bit. And if you trace back and find out where did this 13 Jupiter masses come from, it's a little bit arbitrary. It depends on how much did the planet burn of its energy. If you wanted to be a purist, you might say a planet should be something that fused not a single atom, of deuterium or of anything. But that's actually much lower mass than 13 Jupiter masses. So I think both discoveries are forcing us to revisit what is a planet. They're expanding our horizons. And taken together, they're just an incredible discovery. Does anybody have anything to add to that?
I think you nailed it. Great. And name and affiliation, please.
I'm Joel Achenbach with the Washington Post. Let me just ask several questions if I could. First, are you sure you're looking at the object itself, the planet, and not dust that is surrounding the planet? I mean, how do we know exactly what it is you're seeing in that, in those images? If you give me some sense of also how much light is coming from this object. I mean, how many pixels, or some way to sort of characterize the quantity of information coming from this object. Secondly, is there anything about the disk, about this whole system, that suggests there are definitely other planets there? I mean, is there anything way you can characterize the system to say it looks like there's room for some other planets, or even rocky terrestrial type planets? And third, just to follow up with the first question, Paul, maybe you can directly address this whole issue of priority on this, because the way this press conference has been set up, everyone talked about this as the first image we've had of a planet out there, direct image. But today we're also reporting on these other 3 planets. So if you could just give us some help here about how we're supposed to discuss this when we write about it. Thank you.
Let's do this. You had 3 questions. You had a lot. So give me the first one, and then let's answer it, and then. So give me the first one.
What are we looking at with this? Are we looking at a planet, or a planet plus some dust, or just, is it possible it's just the dust around the planet?
Okay.
That's a remarkable mystery that we have right now. Is the Fomalhaut B is unusually blue. It's not as red as we expect from theory. Noting, of course, that many of these theoretical models have never been tested against observations. So the blueness of Fomalhaut B suggests that it could be possibly reflecting light, and that is possible if it's surrounded by a circumplanetary proto-Galilean dust disk, if you will. In other words, I'm suggesting that this dust disk could be an analog to what Jupiter looked like when it was 100 million years old. And it was surrounded by a dust disk out of which the Galilean satellites formed out of. So even though the observations present us with some mysteries, I think that's actually the excitement we have about Fomalhaut B. We may be going into new directions in physics and new directions in understanding how our own planetary system formed and evolved billions of years ago.
Anyone else want to add to that? Or okay? Okay. No?
Maybe I'd comment that depending on the orientation, half of the light from Saturn can come from its rings. So even in the solar system, sometimes there's sort of a question of whether are you looking at light from a planet or from its circumplanetary material.
Second question.
The second question was, when you look at that whole system, is there anything about it that says there have to be other planets here?
There's something that says it to me, which is the eccentricity of the planet's orbit as inferred from the eccentricity of the ring. It makes me wonder, is there some other planet that has perturbed this planet, has interacted with this planet? So maybe yes.
Our models definitely don't rule out the possibility of multiple planets. And I would add that one of the big advantages we had in doing this particular program was we got a very large amount of time. And if we continue to get that kind of level of observing time to continue to monitor this object, we start to have a better shot at imaging other sources in the system if they're there.
Third question?
Third question, if I can remember it, is just, can you address the priority issue on this and about it? The claim this is the first image. Well, we have 3 others today also. So how do we discuss it?
Oh, well, as Sarah was trying to indicate, both discoveries are extremely exciting for everybody in the scientific community. Fomalhaut B, I'll just tell you where I was when I found it. It was Memorial Day weekend in 2008, and I was reanalyzing all of the Hubble data that we had obtained comprehensively, and I was specifically testing for the presence of planets at that time. Previously, since 2006, we were focusing on analyzing the dust belt itself, because that's also extremely scientifically relevant. And by Sunday of Memorial Day weekend, I had seen this point source as a candidate exoplanet. Now, there are other specks of noise in the image, so the key thing to do is to make sure that what you've seen is not artificial in any way. So I spent 4 days reanalyzing the data again, and in fact did it a 3rd time in July to make sure that Fomalhaut B is confirmed in every data set that we had from Hubble. Then it was actually around July 15th that we learned the other group had confirmed that these other 3 points of light that they found around HR 8799 were co-moving with the star, that star showing motion and properties that would make them planet candidates.
I'll just add one thing. That we're just here today to talk about the Hubble Space Telescope result, a NASA-related result. The other results are not really NASA-related. That's why we're not talking about them. And just for the people who hadn't heard about it, the lead author is Christian Marois and also Bruce McIntosh, and you can call those people and hear all about it.
Okay, let's go to our phones, and please give your name and affiliation, and if you can, direct your question to the appropriate person. And I believe we're going to have Associated Press up first.
Yes, thanks for doing it. Seth Bornstein at AP.